in the beautiful treehouse forest, right?
Yep, yep.
Surrounded by towering oaks, maples, and a massive pine out there,
Oh
going
yeah,
out towards the pond.
so beautiful. You know, the I mean, we can talk about the negative. There's a lot of negative to talk about, but then there's the positive. So what can we achieve?
Yeah, but
What?
first tell us, like, we have this climate change now, a lot of things. So what's going on in terms of that? What are the numbers? What's really the risk? What's going on?
Well, when you look at how we generate our so the reason that we are what we are is because of fossil fuels.
Yep.
So in other words, the availability of cheap energy, abundant energy,
Hmm.
to create all the things that we create, to smelt the metals, to make the electronics, to all the things that we take for granted are, are available only because of our abundant energy. In other words, we would have a totally different lifestyle. Our energy source is the main deal that makes modern society what it is. So that's the first
Yep.
thing you got to tackle is how are you gonna stop this polluting. It puts out CO2. CO2 creates global warming. There's just no two ways about it. So the
Hmm.
first thing you got to do is figure out a way of not having that CO2 going into the air and polluting and causing global warming.
Hmm.
So, the and beautiful and this guy Alvin Weinberg, who was down at Oak Ridge right after the World War II, and we had the atom bomb, and they were looking around and going, how are we going to create, you know, th- boy, this atom bomb thing, boy, fission, it's pretty amazingly intense. Look at how much energy it's given off. Wow,
Yeah.
you know. So they said, oh, let's see if we can do something peaceful with it. Well, of course, the first thing we did was put a motor into a atomic submarine, into a submarine, so we could stay under the water and kill more people. So the first application was obviously, the first thing we did was make a bomb, and then we
Yeah.
made a thing that's destructive, a
Hmm.
warship, the
Yeah.
Nautilus, But,
Hmm.
this guy, scientists being what they are, said, oh, hey, look, we made that motor, but, that thing could drive a generator, or it could heat water, and we can make, hey, we could make something that could make electricity. Hey, let's try and work on that. So they did, and sure enough, they came up with something that works. So here's this guy, this beautiful guy. He goes, "Wow, we can harness, we can actually make all the energy that we need cleanly,
Hmm.
you know, instead of all this fossil fuel and everything." So there's
Yeah.
beautiful promise here. The promise
Mm.
is absolutely amazing. And then he went one step further. He, of course, the U.S. Air Force came along and said, "Well, you got the Nautilus, and we got to be able to drop bombs on Russia and everything during the Cold War, 1950s Cold War, right in the middle." So the U.S. Air Force said, "Well, can't you make an atomic engine for an airplane so we can keep the bombs up there in the air 24/7? We never have to land, and anytime we want to drop a bomb, we can drop a bomb because we don't have to come down and refuel." So, I mean, now if we could just change our mental idea about why are we going to use everything we think of to destroy, let's think of all these amazing technologies to make something happen for the positive. So,
Yep.
so from that, we came up with this thing called a molten salt reactor out of
Hmm.
that. And it took this reactor that was relatively dangerous, and it brought it down into this beautiful thing called a molten salt reactor.
Huh.
And and the guy that invented all the reactors in the world looked at this and said, this reactor that we've just created is the most important thing since fission, since atomic energy.
Hmm.
This is really important, and we got to build this thing. But as usual, humans took this and said, no, we got to do plutonium and everything for bombs and stuff. So this is the reactor we're going to do, not this one.
Uh-huh.
And so here we are, come forward all these years with all our missiles and all our atom bombs and hydrogen bombs and all this crap that we do. And now we're finally starting to realize, hey, we can use these technologies to create a beautiful world that
Hmm.
isn't polluting, that would give everybody a promise and give everybody the possibilities that actually technology could deliver to us if
Yeah.
we just use a little critical thinking.
Yep.
And unless we do that kind of thing, And we can. The promise is there. It's very, very positive. It's actually a miracle. And I'm not a religious guy,
Yep.
but but fission is actually a miracle that has
Mm-hmm.
been given to us.
Yeah.
You can say it's been given to us by God or it's just existing there, but it
And
is an amazing promise.
and thorium is the 90 on the periodic table.
Yeah.
It's a radioactive substance that can do fission energy, right?
Well, it's what they call fertile. So in other
Uh-huh.
words, it's not radioactive in itself. It's mildly radioactive, but it's not like uranium. It's very stable. It's abundant. It's 4 times more abundant than uranium.
Uh-huh.
And as it comes out of the ground, it doesn't need to be refined. It can be used just as it comes out of the ground.
Uh-huh.
No refining. Just
Wow.
take a clump of it, and
Yep.
you can hit that with neutrons, and you're going to create fission. It's
So
through
in
a
the,
process,
the thorium, it's the salt reactor. What's it called? The salt
molten salt reactor.
molten salt.
Yeah.
Is there any way that could be misused? Or is it quite safe to
It,
keep
it
in small, if we have smaller units in the hands of more people?
it's very safe, and I mean,
Can it be misused? Like, what if
everything can be misused.
what if I take a nail and hammer it into one?
No,
Is that
no,
going to be
no. There's
bad?
no way. There's no way that actually even a reactor can explode. But when you see reactors explode, like Fukushima and so forth,
Uh-huh.
those are not nuclear explosions.
Right.
That is because they have these containment buildings
Mm-hmm.
because the type of reactors that are out there now work under 1,000 atmospheres.
Uh-huh.
So you got to have this tremendous because you're boiling water.
Yeah, they get really hot as well.
Well, I mean, but high pressure
Oh yeah, the
because
pressure.
you're getting this steam into high pressure,
Mm-hmm.
and so that's what those containment buildings are all about. Because if there's a leak and stuff gets up into these containers, you got to have a big enough thing to hold that energy. And what happens is, with the explosion you see is that when the rods start to melt down, they create hydrogen. The hydrogen goes up into that thing,
Oh
and if there's a
geez.
little spark, the whole thing blows up. So
Mm-hmm.
what you're seeing blow up is not the nuclear. You're seeing
Right.
this atmosphere this foolish thing that we're building that's
Mm-hmm.
dangerous, and that's why those type of reactors are very dangerous. And then of course they melt down and they go
Yep.
down into the ground, and then you have this molten mess that has very long half lives, and you have to
Yeah.
deal with it.
The nuclear contamination
Yeah,
is
yeah.
a big deal,
I mean, but it's
and
very localized. It's not, in other words, even what happened at Chernobyl, they theorized that it killed so many people. Well, it didn't really kill that many people.
uh-huh.
Even though, and don't forget, humans are built to handle radiation
Mm.
because the sun is a radioactive source. We're getting hit
Yeah.
by cosmic rays. Your skin burns because of the radiation.
Uh-huh.
So there are places on the planet where the natural background radiation is extremely high.
Right.
People do fine. They're not any sicker. They're not any worse off than anybody else. So
Mm.
this whole radiation thing, we have such a scare about it. I mean, it's obviously a place where the radiation will burn you right away, like at
Right.
Chernobyl when you're
Yeah, with
close.
Chernobyl, it's too
Yeah,
much
yeah.
radiation.
Well, I mean, but the people that died there were actually picking these radioactive hunks of stuff up that are giving off intense radiation
Oh
close
wow.
by, and that's why they died.
Yeah.
But as soon as you get further away, the radiation drops right away. It's
Mm-hmm.
unbelievable.
Huh.
Forget it. There's no problem. So
Uh-huh.
we're so scared of radiation, and like I said, the reactors that are out there are not good. But
Right, but with the thorium one, there's no risk for it to be misused
no, well,
and it doesn't put off radiation that's dangerous either, right?
it does in close range. Yes, it gives off very, very dangerous stuff, and some of their daughter products are extremely. So the more destructive something is, the shorter the half life.
Right.
So if you get something with like a half life of 20 days, that's giving off radiation you don't want to be near.
Huh.
Okay, I mean you can shield from it,
Yeah.
and it might be close range radiation, but it's
Okay.
dangerous stuff. It's also great stuff for killing cancer. It's
Uh-huh.
also, and it's used all the time in cancer, actually in all kinds of radiological things to find what's wrong in the body.
Right.
I actually had something done for me where they were trying to find a certain cancer. So They actually created this very short half-life thing right at the hospital,
Wow.
and it's only lasts for probably I don't know. I think the half-life was like 2 hours, 3 hours, and
Jeez.
they couple it with material that will find the cancer. Then they put you in a scanner, and they can see exactly where the cancer is because they can see the radiation.
Wow.
So it can be used as a diagnostic tool. I mean, all
Hmm.
things can be used in good ways and bad ways,
Right.
you know.
Uh-huh.
So, as a matter of fact, one of the daughter products from thorium reactors uh, is it has a half life of, I don't know what it is. I think it's a day or two, but
Hmm.
it can be coupled with a protein that will find the cancer, and it works over microscopic, not even microscopic, over basically molecular distances,
Uh-huh.
so that when it integrates itself into the cancer, it only kills the cancer because it's in that mass of cancer.
Yep.
So it's shooting it out, and it's killing all the cancer cells around it, but it's not killing the good cells. So you can shrink these things just by having this thing with this short half-life that will couple to a protein that'll go to the cancer.
Yeah.
So there's all kinds of fantastic stuff. It's so the technology can be used so much in a positive way.
Yeah. In conclusion, I think there's just huge potential we have not tapped in terms of energy creation, in terms of, treating conditions.
Yeah, yeah,
And, we have so much that we can develop, so much more we can learn.
yeah.
And that's what I'm really excited about because we can apply these technologies and use them to create a better world.
We sure can. I mean, the promise is unbelievable.
Yep.
But the if we could just overcome our, I don't know,
The
our
mentality.
humanness, that human flaw. I don't know. What do you want to call it?
Yeah. Well,
Is there,
that might be a topic for another
I
day,
know.
right?
Yeah,
Because I think that it's not just humans in general, but also the top powers that should be the ones that are focusing on this, where they're
yeah,
focusing energy on different things.
yeah, absolutely.
So
And
I
and,
think
and,
that the
and
responsibility is theirs.
and that's a real question: is how is it that these people that have all this resource, like let's say the Elon Musks of the world,
Mm-hmm.
why is it that they're not focusing? I mean, Bill Gates is focusing on what they call a traveling wave reactor, which is fantastic. That's what these guys should be focusing on. They have the money,
Mm-hmm.
they have the technology. They're smart. It's not that they're dumb people, but they're just choosing not to do the positive things for humanity. It's just, it just is kind of frightening. Like to go to terraform Mars is the wrong thing to do now. Let's save the planet first and
Mm-hmm.
then terraform Mars if that's what you want to do. But
Yeah.
don't do that first. Don't take all that beautiful technology you have and focus it down into how we're going to make this planet a beautiful place for everybody.
Yes.
You
And
know?
that's what we want to see is a beautiful planet
Yeah, a beautiful
for
planet and everybody,
everybody,
prospering. We all want people to prosper,
Yeah,
don't we?
exactly.
I love you. I
Yeah.
love people.
Yeah.
There hasn't been one person I've ever met in my life that I didn't love until I got to know them.
Yep.
Then there's a problem.
There you go.
But if I see you going down the street, I love you until I know a little bit more about you.
Yeah, that's right.
I want you to be happy. I want you to be
Yeah.
happy.
All right. Well, we'll leave it there. Awesome.
Okay.